Okay, today we are working with product rule and quotient rule. Product rule and quotient rule, and this pertains to specifically derivatives. Derivatives of products and quotients. Now, we talked about easy derivatives so far. You're going to submit the work through Schoology. It's like a quiz, online quiz. Just going to submit it and I'll grade you right away. So if I ask you guys, y is equal to x cubed, and I ask you find the derivative of y, that's the same thing as writing as d over dx of x cubed, right? It's almost like a substitution problem. That's the way of writing this. This problem is quite easy because the derivative is just the power rule, which is 3x squared. Done. Don't write the d over dx because we did the process of finding the derivative. We're left with 3x squared. Power rule, super easy, super sweet. But what if I'm multiplying things together? Oftentimes in math, we end up multiplying things together. And let me write that out. D over dx of x squared times x cubed. So this is what I'm asking you guys to take the derivative of. Now, of course you can multiply these things together. You could have wrote x to the fifth, right? When we multiply powers, we add the exponents. And we could say the derivative of this is going to be 5x to the fourth. But what if you end up with a problem in which you couldn't easily multiply? So we're going to use this as our launching pad to see what the product rule is. So here's the product rule. I'm going to write it out, okay? Product rule. We'll say f and g. Oops. And g. No, darn, that's an and sign. Let's write it out. F and g are both differentiable. So we can take the derivative of this. So the derivative of f of x times g of x is going to look like this. Looks like a mistake, but it's going to look like this. Just take the derivative of the front, leave the back alone, plus the derivative of the back, leave the front alone. Okay, this is slightly different than the way it presents it, but I find this is easier. Okay, so the derivative of things that are being multiplied always follow this pattern. Take a derivative, see this little symbol? That means derivative of the front first, leave the back alone. We're just going to copy the back. Plus the derivative of the back, leave the front alone. Okay. Now, if we use this as our pattern, if I say f of x is x squared and g of x is x cubed, okay, I'm going to take one step for you guys. Let's take the derivative of these here. I don't recommend you do this later, but I want you guys to make sure you see the pattern. F prime of x, oh, that looks ugly. The derivative of f of x is 2x. You guys feel comfortable saying that quickly? And the derivative of g is 3x squared. Okay, hopefully you guys feel comfortable with that too. Okay, so if I just say the derivative follows this pattern, okay, f and g, and we're going to plug in all these parts. We have all four parts here. Okay, it's going to look ugly. It seems like, why are we doing it this way? No, what? Not that bad. So d over dx is f times g. That's copy f and g. F times g, right? That's what we wrote on the previous example up here. That's what we wrote up here. I'm using our definition. We're just going to plug in the values. Well, first, take the derivative of the front. The derivative of the front is 2x, right? That's f prime. Leave the back alone, right? That's just g. I'm going to erase this. But take a look. See that? That's f and g? F prime and g. Plus derivative of the back. We have that written already. That's going to be 3x squared times f regular f So I want you guys to be able to make sense of all this stuff. Make sure you understand where I got all my pieces from. Derivative of the front, leave the back alone. And the derivative of the back, leave the front alone. The blue is my original, and the red is my derivative. Okay, let's go ahead and simplify. This is going to be 2x to the fourth plus 3x to the fourth. Oh my gosh, that's 5x to the fourth. So, which one was easier?
The top one.
Yeah, if you could simplify the problem, do it. Great. Okay, but this rule works. Okay? And the idea is that if I simplify or I don't, we have rules to work with these problems. And in this case, if I have to deal with them separately, fine, we can do that. And that's what you guys are going to practice today. So we're going to work on the problem. The problem goes derivative of the front, leave the back alone, then derivative of the back, leave the front alone. Remember that, derivative of the front first, front, time, and then we're going to leave the back alone. Leave back alone. Plus, derivative of back, leave the front alone. So this always reminds me of a story I heard about Disneyland. Imagine if you and your significant other, and you guys have a kid, bratty little baby Co, and you want to go to Disneyland. You want to go Splash Mountain. But little bratty little Co is too young to ride Splash Mountain. Disneyland has a rideshare program. What I mean is, I forgot they have a term for it, but here's how it works. Let's say we want to go on Splash Mountain, but we have a little child that we have to worry about, and we can't take this little child to Splash Mountain because they're too short or too scared, like my kids. So, but I really want to ride Splash Mountain. My wife really wants to ride Splash Mountain. So here's what you do. You hop in line, go through the line, and once you're at the seating area, you tell them, we want to take turns. So here's what it looks like. I hop on the ride first while my wife sits waiting for me. After I come back, my wife gets to ride the ride while I sit there and wait. We're taking turns, essentially. And that's kind of what you're doing here for product rule. You're just taking turns. Derivative of the front, leave the back alone. Derivative of the back, leave the front alone. Does this work if I swap it? Yes, it does, but I wouldn't. I just rather you guys memorize it one way. Okay, let's try another problem. D over dx. Whoops. So we're taking turns. We're going to write x cubed plus x squared times x to the fifth. Here we go. Okay, so let's do this by distribution. Let's multiply this out. This would be the derivative of x to the eighth plus x to the seventh, if I'm correct. And we can do this derivative very quickly, super fast. Derivative of this will be 8x to the 7 plus 7x to the 6. Okay, using power rule. We multiply our function to simplify it, and then the derivative of addition means you take the derivative of them separately. Anyone have a question on this part? Okay, let's go ahead and take the derivative now. Of them as a product. D over dx, x cubed plus x squared times x to the fifth. Okay, so you could set this problem up, and if you need to, fine, call this f and call this g, and f is x cubed plus x squared, f prime is 3x squared plus 2x, g is x to the fifth, g prime is 5x to the fourth. You could do this, okay? You could do this. And when we're learning how to do this, sure, write it out so you have the parts. Okay? So the derivative rule, remember, you go f prime g plus g prime f. We take the derivative of the front, leave the back alone. Derivative of the back, leave the front alone. Derivative of the front, leave the back alone, plus derivative of the back, leave the front alone. Okay with the pattern? Okay, we're gonna go ahead and copy that down. Derivative of the front, you said was right here. That's gonna be 3x squared plus 2x. Leave the back alone. And then derivative of the back is plus 5x to the fourth. Leave the front alone. Taking turns. And then we can distribute if we want. So on the homework right now, the first like 8 problems are like set it up, you're done. Set it up, you're done. The next like 24 of them, you're gonna go ahead and multiply it out. 5x to the 7 plus 2x to the 6. I think that's right. 5, 6, 7, yeah. Oops, I made a mistake here. That's a 3. It's a 3. Yep. And then plus 5x to the 7 plus 5x to the 6. I think that's right. We have like terms. I see x to the 7, 3 and 5 make 8, and 2 and 5 make 7. Oh my gosh, it worked. Better work.
I have a question.
Give me 1 second. Okay, let's do another problem now. So d over dx, and the problem is x squared plus 3. Oh, actually, no, let's do it this way. X squared times the square root of x. Okay, x squared times the square root of x, yeah. So if you really want to rewrite it, because you could do it in this case, you can't do it for most cases, you could rewrite it as x squared, x to the 1/2, and this becomes d over dx, x to the 3, no, 2 and 1/2, or 5 over 2, okay, if you want to rewrite it, okay? Not the most eloquent way. But if we wanted to, this becomes x 5 over 2, x to the minus 1, minus 2 over 2. That's my minus 1, right? That's going to be 3 over 2. Okay. You guys have to make sure you guys are practicing this yourself. Okay, let's do product rule. So here is me doing product rule. You could write all of this, and this is super helpful for a lot of people, and please write it if you need to see it. But I'm just going to talk my way through it. The derivative of product rule means take the derivative of the front, leave the back alone. Okay, was that too fast? Let me slow down. Do it again. The derivative of the front, x squared, is just 2x, bring down the exponent, minus 1, and we leave the back alone. Nope, same amount of time. Plus, product rule is always a plus. Plus the derivative of the back, which is, oh, careful, this is x to the 1/2, right? So be careful about that. So it's 1/2 x to the negative 1/2. That's the derivative of the back. Leave the front alone. That is our setup. We want to simplify this. Let's write this as x to the 1/2 again to make our lives a little easier. This is 2x 3 over 2 plus 1 over 2 x. This combines to become 3 over 2 also. Common denominator, 2 over 2, gives me 4. 5 over 2 x 3 over 2. Same answer. Woo! So in this situation, you could have rewrote it. But in most square root situations, you cannot rewrite it. Because these had the common x, we were able to rewrite it. Now, product rule is super important for us because we'll see other types of derivatives. Now, I'm going to give you one right now that says this, d over dx of, let's do x squared again, and now sine x. Now, you can't mix sine x and x squared. That doesn't become sine x cubed. Okay, if you took pre-calc at all, you realize that's not true. So here's what we do. Call this f and call this g real quick. So f is x squared. F prime, whoops, darn it. F prime is 2x. G is sine. And I'm going to tell you what the derivative of sine is. It's going to be cosine. Turns out the derivative of sine is cosine. So knowing this, we're going to rewrite it as derivative of the front, which is 2x, leave the back alone, plus the derivative of the back, which is now cosine, leave the front alone. If only you can rewrite this a little nicer, 2x sine of x plus x squared cosine of x. Now, when do we need the product rule? Whenever you are multiplying two functions together. That's product rule.
Can you simplify that answer anymore? Or is that just the final answer?
Because it's sine and cosine, you cannot simplify it anymore.
Okay, that's what I thought.
Unless if it was sine squared plus cosine squared and the front coefficients were the same. Yeah. Okay. So that's the idea of product rule, and you guys will practice that. Now, let's do quotient rule. Now, quotient rule, let me write it out for you. So let me say quotient rule. Okay, quotient rule. Now again, the book will rewrite this definition differently. And they write it in what I find not always the best way to remember, because I always forgot about it. So here's the rule. D over dx of f over g. Let's write it this way as a nice brief way. It's going to be the derivative of the top, leave the bottom alone. Hey, doesn't this look just like what we wrote before? And it is. Minus though, because of division, g prime, okay? Leave the front alone, all over the bottom squared. Let me say this again. Derivative of the front, leave the back alone. Front, back. Then derivative of the back, leave the front alone, over the bottom squared. Derivative of the front, leave the back alone. Derivative of the back, leave the front alone, and over the bottom squared. That is our rule. Let's go ahead and try a problem. D over dx, and we're going to say x over x squared plus 1. Okay? So you can't simplify this. You can't simplify. You can't just divide the x's. Oh, Mr. Code, the x's divide out. Nope, they can't because of that 1. So I'm going to take my time here just to help you guys out. F is x. F prime is 1. G is x squared plus 1. G prime is 2x plus 0. Don't write the 0. Just so you guys have the parts. So derivative of the...
Wait, why for G prime do you take away the plus 1?
Okay, so what's the derivative of a constant? We said that was 0.
Oh, my bad.
It's okay. Good question. So we're going to fill it out. Derivative of the front. Leave the back alone. See, I wrote this guy, not this guy. This guy, right? Because we want the pure version, not the derivative version. Minus the derivative. Leave the top alone. All over the bottom squared. And then we can simplify this. X squared plus 1 minus 2x squared over x squared plus 1 squared. We're going to simplify one more time. These are like terms. Negative x squared plus 1 over x squared plus 1 squared. Okay. Now, that's the process, okay? The process is you have to straight up memorize this. Now, I want to show you how we came up with it. How did we come up with it? Okay, all right. D over dx. So what if I write it as, what if I write this instead as this. Remember how we write things on the denominator on top of the negative exponent? Okay. There's also one rule that I haven't taught you yet. But I'm going to just plug it in right now, okay? And it's called chain rule. But we're going to work on it right now so we can show you guys that this is the same thing. So if this was a product rule, who do we take a derivative of first? We take a derivative of f, right? F prime, leave g alone. Everyone see what it did there? Take the derivative of f, call f prime, leave g alone. Leave the back alone. Plus, okay, what's the derivative on the side of g inverse? Oh, not g inverse. G to negative 1 power. That's going to be negative g to the negative 2 power. And then I need to write one more thing. It's called g prime. That's chain rule. You guys have not learned this yet. Chain rule, but we need it for this proof. But we'll learn it in like the next day. You call it g prime. The derivative of g is g prime. So we're going to write negative g, negative 2 power, g prime. Leave the front alone. Okay. Let me pause here. Answer any questions. Okay, that's simplified. Now, remember how this is a negative 2 power, negative 1 power? Let's rewrite it. It's going to be f prime over g plus, so let's write that as a negative sign now. This negative here, right? The negative. Negative g prime f over g squared. You guys feeling that okay? Let me show that again. This squared, right? That's negative. That's why you're on the bottom. But g prime and f are both on top. Now, to combine the fraction, we need a common denominator. So we need a g squared. So I need to add another g to the top and bottom. So we need g over g. So we have a common denominator. We are rewriting now with f prime g minus g prime f over a common denominator of g squared. Imagine the guy who came up with this. Gosh, I think it must have been some type of genius or something.
Was it you?
You're so sweet. No. Remember the idea of calculus, I think, was invented by Newton to describe physics. So this is all related to physics. And they're all totally interconnected. That's the crazy part. Okay. All right. So just to prove that the quotient rule is really the product rule, just rewritten. This is what it is. Okay. Okay. Call it. Okay, let's do quotient rule one more time. Okay, d over dx, and the problem is going to be x squared over square root of x. Okay, and you can rewrite this as x to the 1/2 power if you really need to in your heads. Okay, derivative of quotient is derivative of the front, leave the back alone, minus derivative of the back, leave the front alone, over the bottom squared. Okay, that's our pattern. Make sure you guys are writing values down in your notes. That's you with your video on, not writing anything.
I wrote it out already.
This? You did this already?
Yeah.
Oh, that's pretty fast because I just wrote it. Fancy. 2x, leave the back alone, minus the derivative of this is 1/2 x to the negative 1/2. Oh, that's ugly. And leave the back alone over the bottom squared. Okay, please make sure you are cool with all the parts. Derivative of the front, then the derivative of the back, of the bottom. Right? Those are related, right? To rewrite this, it's going to be 2x squared of x minus 1 over 2 squared of x, x squared over x. You could probably simplify this, get rid of all the x's here. See, these are all x's, right? So if I want to rewrite it as 2 squared of x minus 1 over 2 squared of x times x. Something like that. Okay. So the big takeaway for taking the derivative of quotient rule problems is that just stick to the rule. And if you deviate from the rule in any way, I almost guarantee your problem will be wrong. Stick to the rule. And the rule is up here. Derivative of the front, leave the back alone. Derivative of the back, leave the front alone, all over the bottom squared. Okay, and if you write it this way, this is how the book writes it, pretty much. But the product rule is not how the book writes it. They actually always flip it around. They always flip it around. Where's my rule? They always flip these around. But I don't flip them around because this looks just like the quotient rule, except for a minus sign. Okay. Hopefully that's helpful. So if you guys remember the rule, if I take the derivative, d over dx, of 3x squared like we first started with, okay? And we just said this is a constant multiple. So we just ignore the 3. We'd say 3, sit back, relax, enjoy the ride, and we'll do all the work with the actual x squared in the back, right? Hey, this is a product rule problem. If I treated this as a product rule, what's the derivative of the front? What's the derivative of 3? 0. Leave the back alone. Plus the derivative of the back, leave the front alone. This is same answer. The product rule works here, even with a constant. But why do it? Because it always goes to 0, because it's always a constant, which is super cool. Yeah. Anyways, all right, cool. Did it.